This is my lesson TV, and we are going to continue with our lesson on circle theorem. So the previous video we talked about the parts of the circle. Okay, we said this is the diameter, and the diameter is a special chord. Is the chord that divides the circle into two equal halves. Okay, and also you can see that this is the longest chord. Okay, because of all the chords that we have. So this one chord, this is another chord, this is also another chord, but if you measure their length, you see that the diameter is the longest chord. Okay, so now let's box on to the first theorem. Okay, so theorem 1. So theorem 1, please pay attention and make sure you understand. Okay, make sure you understand one theorem before you move to the next theorem. Okay, so the first theorem states that the angle that an arc, okay, so the first theorem says that the angle an arc subtends at the center of a circle. Okay, so we learned that this is the arc. So the angle that an arc subtends at the center of a circle, this is the center C. Okay, this angle, the angle from here, is twice the angle this same arc subtends at the circumference. So that's here. So we are saying that, I think I should do that with a pen. So you are saying that the angle that the an arc subtends at the center is twice, okay, please note that it's twice the angle that this same arc subtends at the circumference. Okay, so let's say this is angle A and this is B. Okay, so we are saying that A is equal to 2B. Okay, A is equal to 2B, or B is the half of A, something like that. So what about a segment? Sorry, it's supposed to be, what about a chord? Okay, this in case we put a chord here, let's say from A to B, I put a chord here. Now this chord is subtending an angle at the center, and this same chord is also subtending an angle at the circumference. Okay, so you can also say that the angle a chord subtends at the center of a circle is twice the angle it subtends at the circumference, okay, of the circle. So kindly note that. So this is a rule that has been established. So let's find out whether this rule is true. Okay, let's play around to understand. So that's the first rule. You solve questions after this. So now let me take I inscribe a circle. Okay, so let me beep in. Oh, double lines. Okay, so this is a circle. Sorry for making these oval lines. So that's a circle, okay, and this is the center highlighted here. So I'm going to inscribe so the arc, I made a point here. So from this point to that point we have an arc. Okay, so this arc is going to subtend at an angle at the center. So I'm going to do that. I'm going to draw a line from one point to the other. Okay, and then from here to there. So I'm going to do so, trying to see whether this theorem is true. So we have that. So this same arc is going to guys, I'm referring to this arc, okay, the arc here. This same arc is going to subtend an angle at the circumference also. So from here to there. So they said any point on the circumference. So after this, I'll choose another point and draw the line from the arc to that point that I'll choose. So I want to measure these angles, okay, and see whether this angle is twice that. So let me use a protractor. Let me use a protractor to measure. Okay, so I put the protractor here. And as you can see, this angle, I hope you can see well, is close to 60. I think it's 60. Yeah. So this angle is 60. So the angle at the center is 60 degrees. So this is 60 degrees. Let me indicate that. So 60 degrees. Okay, so I'm going to measure the angle at the circumference. So this angle is this angle is 30, as you can see. Okay, I'm reading from here. So it's 30. So that's 30 degrees. So we can see that 60 and 30. But we can see that 30 times 2 will give us 60. So we can therefore say that the angle subtended at the center is twice that at the circumference. Let's try another point on the circumference, because they said at any point, okay, on the circumference. So let's try, let me draw from here to there. So this is the arc, okay, arc say AB. So I'm drawing from there. Okay. So this arc also gave an angle of 60 at the center. So that means that the angle subtended at the circumference must be 30, okay, according to the theorem, the first theorem. So let me measure this angle and see. Wow, it's also 30 degrees. Okay, so you can see from measuring from the baseline from here to there, you can see that's 30 degrees. So here it's also 30 degrees. Let's choose another point on the at any point on the circumference. So let me choose this point. Okay. Oh, so we are expecting this angle to be 30. Okay, so let's see whether that is true. Sorry, that's this point. Wow, it's also 30 degrees. So that confirms that mass is not a lie, okay? Mass actually proves what is going on. So you can see that the angle is true. That, where's the rule? Okay, so that's it. The first theorem states that what? The angle an arc subtends at the center of a circle is twice the angle it subtends at the circumference of that same circle. So we can see, we've actually seen that it is true. So we can actually form any angle. Let's say inscribe an arc to this point and draw lines to that place. We can see that that will be true. Okay, the theorem will be true. We can see that, we can also see something here. Look, let's look very carefully. You can see that all the angles subtended by this arc, or say, let me put a chord here, subtended by this arc or chord, they are the same. So that will be a topic, sorry, that will be a subtopic for another time, for later time. You look at that, but just remember this picture. Okay, so we can now solve questions. Let's try our hands on this question. So we have a question that states that we have a figure here. Please, this circle is not drawn to scale. Okay, it's not drawn to scale. So this is the center O, and this is, I'm choosing this arc, say PQ. So I'm choosing this arc. So this arc is subtending an angle here at the center and then an angle at the circumference. Okay, please, it's not always that this arc will subtend an angle at this point also. It can be here, okay, in order to trick you. So they can also bring another diagram. Sorry for this sketch, it's not perfect though. So they can bring this arc and then subtends an angle here and then an angle there. Okay, it's still the same rule. Okay, so we are given that the angle here is 80 degrees. Find x. Okay, PQR. So it's just, you can see, you just say that x is equal to what? 80 out of 2, and that is 40 degrees. That's your answer. So you can say that by theorem 1, Or you can just go straight away by theorem 1. Let's say the same in case here is say 80. Let me choose another number, say 84. Okay, this angle here will be half of that. Okay, so here is going to be what do you think to be? Yes, you are right, that is 41 degrees. Okay, so this shows an so the question can be that figure that shows a circle with center O. The arc PQ subtends an angle 80 degrees at say center O. The angle PQR. So they are saying that angle, this is a short form for an angle, okay? So angle PQR is equal to 80 degrees. So you look for angle PQR. Angle POR. Okay, sorry. Angle POR. Angle POR is 80. Then you also say that angle PRQ. Angle PRQ. So you need to put your X where here. Angle PRQ. This angle is X. So therefore then you can do it. Okay, thank you very much.